So some doubts related to the past paper, paper 4, IGCSE physics. So figure 8.1 shows a metal rod. As you can see, there is a metal rod that is suspended in a magnetic field produced by a pair of a permanent magnet. So the magnetic field is produced by the permanent magnet. What is the direction of a magnetic field? The direction of a magnetic field is from north to south. The metal rod is connected to a cell and there is a current in the metal rod. So what is the direction of the current? We always take the direction of a conventional current, and the conventional current always flow from positive to negative. So the current will flow in this manner. So this is the direction of the current. The question is state the direction of the force on the metal rod due to the current. Whenever, how you will know, because that is a main confusion among the student, that whether we have to use a left hand or a right hand. So whenever you see any supply is there in a question, like you see a cell is there, a battery is there, or a power supply. So in that case, you will use your left hand, the Fleming's left hand rule. So in a Fleming's left hand rule, your index finger, your first finger representing the magnetic field, or index finger represent the magnetic field, which is pointing towards the south. My index finger of the left hand should point towards south. My second finger represent the direction of the current. So my first finger is pointing towards south. My second finger is representing a direction of the current. Where the thumb is pointing downward. So the force is pointing downward. So what is it? The question is state the direction of the force. So what is the direction of the force in this question? The force will point downward. And how I will know which rule I have to use, a left or the right hand rule? If you see a power supply in the question, like if there's a power supply, then you will use the left hand. If you don't see any power supply, like you see a wire is there and a magnet, and there's an induced current, then you will use your right hand. So what is the direction of the what is the direction of the force? In this case, when we apply the left hand, the direction of the force is downwards. What about the explanation for this force? Explanation for this direction of the force. So the reason is that the current is perpendicular to magnetic field. Because when the wire is parallel, it won't experience a force. So current is parallel to magnetic field. The magnetic field, I'm writing it here, the remaining answer. The magnetic field of the current, because the current produces a magnetic field, so the magnetic field of the current interact, or you can say cuts, the magnetic field of a magnet which cause force on the wire. So what actually happened, why there is a force, the explanation for having a force or the force is acting. One is the magnetic field of the magnet, like the magnetic field of a current, which is circular, and one is a magnetic field of the magnet from north to south. So there are two magnetic fields. So when these two magnetic fields interact with each other, that cause a force on the wire. This question, two magnets are there in a cell, are used to make a simple DC motor. A DC motor convert the electrical energy. The DC motor convert the electrical energy to kinetic energy. When there's a current is passing through a wire, it produces a magnetic field. One side of a wire experiences a downward, another side upward force. This causes a rotation of the wire. So the DC motor has a converted electrical energy to kinetic energy. Now the question is describe the function of the parts J, K, L, M. First, you have to identify these parts and then explaining a function. First, what is part J? Carbon brushes.
They will conduct electricity without breaking the wires, without the wires.
Yeah. So carbon brush. And what is the purpose of the carbon brush? You can also mention it is to connect the cell with the coil. You can also say it connect the cell, the power supply with the coil, or it is preventing the twisting of the wire. It's a fixed contact, like same way like we are using a plug. If I want to provide electricity to any device, I just plug in that device. So that's the purpose of the carbon brushes. So the purpose of the carbon brushes is to connect the supply with the coil. No. Complete the circuit is different. Even other than carbon brush, if you don't use any conducting material, it will also complete a circuit. So the main purpose is to connect the supply with the coil. Like there's a connection between the supply and the coil. So how? That is by the carbon brush. The next is part K. What is part K? Part K is coil, wire. The purpose of because coil, it's a conducting wire is there, rectangular coil is there. What is the purpose of the coil? The coil can conduct electricity. Allow the charges to flow. So the main purpose of the coil is to conduct electricity or allow the current to flow. That is the purpose of the coil. Next is L. What is a L? L is axle. So coil, So coil can rotate about a fixed point.
We can also say that.
So acting like a pivot for a point of rotation. Around this point, the coil will rotate. So when we have this L, so the coil will rotate about this point. So one side of a coil experience a downward, another side upward, and the coil will rotate. But this point will remain fixed. So what is the purpose of the axle? Act as a pivot, point of rotation, or help in rotation of the coil.
So this is DC.
This is a DC motor.
So can we say that to rotate the
Yeah, to rotate the coil, that's the same thing.
Like an AC, like to rotate the fans, turbines.
Yes, not turbine, you can say rotate, rotate any other device which is connected to them. We can connect anything like, for example, if I connect a fan here, then the axle will rotate because the fan will also rotate. So that I can also mention that as a use. The last point is M. What is it?
The direction of the current after
M is a split ring.
After half rotation.
And what is the purpose of the split ring? Reverse the direction.
After half rotation of 180.
After 180-degree rotation.
Sir,
Or can you say half rotation?
Split ring.
what is the difference between split and slip ring?
Split ring is used in a DC motor. Slip rings are used in an AC generator. The split ring allow the current to change the direction after 180-degree rotation, but slip rings does not. It remain in contact throughout. So from the picture, you can identify if you see the rings are like this, it means these are the split rings. So this is a DC motor. But if you see the circles are there, two separate circles are there in the carbon brushes, this give an idea, it's a slip ring, and slip rings are used in AC generator. AC generator, we rotate, it produce electricity. DC motor, we pass the current, it rotate. So two are opposite. One convert electrical to kinetic, the DC motor. AC generator is like how we produce electricity, like we are using electricity in our home, how we are using it by generating. So what are the generator? All these generator works on the same principle. Rotating a coil in a magnetic field produces the induced current.
So sir, in AC, we rotate the axle by ourselves. Like that.
We rotate the axle by ourselves. But in DC, that axle, we pass the current, it rotated.
But they say define slip rings.
No, they don't say define slip ring. Like they will say purpose of a slip ring. So if they say like, what is the purpose of a slip ring? No, slip ring. Carbon brush remains the same. Carbon brush connect the supply with the coil. Carbon brush connect the internal and external circuit. If they ask what is the purpose of the slip rings or slip ring commutators, like with the carbon brushes, so the main purpose of slip rings allow the current to flow in both ways. Like the wire will remain contact every time when the coil is rotating. Yes, and so the wire will remain in contact every time when the coil is rotating. But in a DC motor, what happens when the coil is rotating, some parts, the coil loses a contact with the circuit. Internal and external circuit, they don't have any contact. So DC, we want half to pass, then stop. But in AC, we want the current to flow continuously and changes the direction.
And
If you, for a DC motor, you will use a left hand. For AC generator, you will use a right hand. It will come again because he sent that bit.
AC right hand, DC left hand.
We are AC right hand, DC left hand.
That last second.
930. Strontium 90 is used to measure the thickness of a metal sheet in industry. The strontium 90 emitted beta particles which pass through a metal sheet to a detector. So what we are doing, like we have a radioactive sources there, and we have a metal sheet, and we have the detector. Okay, and we are using strontium 90 as a source here. One metal sheet is 0.75 millimeter thick. Suggests why strontium 90 is suitable radioactive source to measure the thickness of the metal sheet. And they mention it's a beta emitter. So, yeah.
So beta can penetrate through the aluminium.
Beta-
But some of them will be stopped due to the.
Yeah. So you can also write a reverse argument. What you can say alpha will not be suitable because alpha will be stopped by the metal sheet. Like even the thickness of the metal sheet changes, the alpha won't pass. Even it's a thin or a thick, alpha will be stopped. Gamma will not change at all. It's only 0.75 millimeter thick. So if you use a gamma radiation, all the gamma radiation will continue to pass. It won't change the value. But what happened with the beta, the moment the radiation changes, like the moment the thickness changes, the amount of radiation which are passing will also change. So when the foil get thicker, the radiation will decrease. If the foil get thinner, like the metal sheet get thinner, the radiation will increase. So one metal sheet is 0.75 millimeter thick. So what is the reason for that? Like why we use a beta? Beta can pass, or a proportion of beta can pass. Can pass through the foil and changes the value on detector if the thickness changes. But you can write a reverse argument here. Reverse argument means like, because we want to say why beta is suitable. So I can say why alpha is not suitable and gamma is not suitable. I'll also score the mark. Like I will say alpha is not suitable because alpha will be stopped by the metal. And gamma is not suitable because even the thickness changes, the gamma won't be stopped by that
So do
metal.
we say
So it
about-
means we are left with only beta.
Will we say like talk about both of them, like alpha and.
Yeah,
gamma?
why alpha and gamma are not suitable, then reverse argument is like two ways you can write the answer. Either like thickness changes, that will change the amount of a beta particle, or alpha is not suitable because it will be stopped completely. Gamma is not suitable because it won't be stopped at all. So you are left with only beta. The next is the half-life of a strontium is approximately 27 years. Means after every 27 years, the radiation will become half of its original value. The strontium 90 is replaced with a new after 15 years. Suggests why strontium 90 that is more than 15 years old need to be replaced.
So there will be less
Look-
beta emissions due to which. Like,
Yeah, The amount of radiation after 15 years, what will happen? That will change. it will change about how much proportion. It looks like about 60% of the original value of, or let's say, because it is in between. So this will be half with 25, 12.5. This will be about 70, 62, like this value, because it is in 62.5 in between. Approximately, I'm thinking. So means after 15 years, the radiation will decrease to like 60, about 60% of its original value. So the change in the radiation is due to the emission rather than due to the thickness. Like what we are doing, we are using the radioactive source and we are finding that the thickness is uniform. But what happened if it was emitting out 100 radiation after 15 years, the same source is emitting out lower radiation, like it is emitting out, let's say 62 radiations. And maybe out of 100, let's say out of 100, like 40 radiations were stopped or 50 radiation were stopped. So 50 were able to pass through. But out of 62, if 50 are stopped, what will happen? Only 12 radiation will be able to pass through. So inaccurate result will be there because a smaller proportion of a radiation will be able to, because how many radiation are absorbed depends on the thickness. Let's say this thickness is absorbing 40 radiation. So when it was 100, it's easy to detect on the detector that the radiation are absorbed and the value has changed. But when the radiation, like with a half-life or after 15 years, the radiation will decrease to a smaller proportion. So we'll not be sure that this change is maybe due to the change in the detector reading, like the thickness, or due to the change in source. Like if a source is changing, it's hard to recognize. Or a smaller proportion of the radiation will be able to pass through. Yeah, you can take. Right. So strontium 90 source is there with a new source after 15 years. So using a figure suggests why strontium that is more than 15 years old not needed to be replaced. So why we have to needed to replace this? The proportion of the radiation or the radiation from the source will decrease significantly after 15 years. So the proportion of the radiation detected by the detector will decrease. So as a result, when we are recording a smaller change is there, we will have a greater uncertainty in the result. Like the smaller changes are hard to recognize as compared when you have a large change. Is it clear, this one? This is the same question, the first one. Next is we have a figure 7.1 shows a solid block made from a hot liquid metal. So you can see a hot liquid metal is there, bubble inside a metal block. As a liquid cool down, the bubbles form inside the block, and the bubbles are not visible from outside, like because it's a metal. So from a metal, we cannot see inside, it's an opaque. Describe and explain how would you will use an ultrasound to determine the size and the position of the bubbles inside the metal block. First, how we will determine the size or the position. So what we will do, we'll use the source of the ultrasound, the transmitter. The ultrasound will send the signal and it will bounce back from the boundaries of this bubble. And the proportion which is bouncing back, because when the density of a material change, the proportion of reflection will also change. Well, like example, if it is reflected from dense object, if we have a dense object, then the proportion of the reflection will be higher. If we have a low density material, the term transducer means something which can be used as a source and the detector we call transducer. Or the term transducer means the device which can change from one form of energy to another. Like example, your mobile phone is also a transducer. Your mobile phone can also convert from one form of energy to another. So anything which can convert one form of energy to another, we call that as a transducer. So we will use a transducer. Like a transducer means a device which can convert one form of energy to another, or a source of a ultrasound. That is first thing. So the ultrasound will send the signal and it will bounce back and will record how much time it will take to receive the signal. Using this, we can determine the distance or the position of the bubble. Like we will move this detector all over the metal and will record how much time it is taking to return or we receive the pulse back. And we'll use a formula. We know the speed is equals to distance over time. So if this distance is d, the radiation or the wave travel and it bounce back, so the distance will be twice. So it will be 2d divided by t. So if I need the distance, like how far this is, so it will be speed multiplied by time divided by 2. So I'll know the distance. So the speed of the ultrasound means the sound wave actually in the metal, and the time it take to reflect, the time we receive, take to pulse to return, divided by 2. So that will give us the distance between the transducer or the source of this ultrasound and the bubble. So how we'll get the position of the bubble? Because two things are there. The question is how this explain how we use the ultrasound to determine the size and the position of the bubble. Okay. So first thing, how we determine the position of the bubble, we move the, like we'll use a source of ultrasound. So we send the signal and we receive back and record the time we take to receive back. Then the time multiplied by speed of the radiation. The term transducer means the device which can convert from one form of energy to another. Like your mic, a microphone is also a transducer. A microphone can convert a sound energy to electrical energy. So anything which convert one form of energy to another is known as the transducer. So you have the source of ultrasound, which is sending the electrical energy converted into sound energy, which send the ultrasound, like the sound waves, higher than 20,000 hertz, and it bounce back. So we record how much time it will take to return. So the speed of the ultrasound in a metal multiplied by time it take to return divided by 2. So what we'll get the distance of this bubble from the site. Will the transmitter such as big ultrasound, which will give a equal to whole side of a block, which is a square, would we remove this many times that different level or not? No, we can change the position. Like we can, this is a small, usually a small source and a detector. So it's like it send the signal, and the signal strike and it bounce back. So we record how much time it takes to return. So speed of the ultrasound is known in the metal. The time for the receiving this divided by 2. So what we'll know? We'll know how far this distance is, like distance from the detector till the bubble. That's what we do. So we place the transducer, the source of ultrasound. You can also mention an ultrasound source we can place on the metal surface and send the signal and record by using a transducer or a detector. We record and using a time it take to reflect multiply by speed of ultrasound divided by 2. That will give us the distance. Yes, mentioning the formula, it is important, or explain the formula in your own words. Like you can say the speed of this ultrasound multiply by the time for the pulse. Pulse means like a small signal is there divided by 2. So that will give us the distance of this bubble from the source. The second is how we determine the size of the, so how we determine the size. So we'll receive the, like when we send the pulse from here, the pulse will send and receive. So that will be like T1. Then we send another, like the pulse, some of the radiation will be able to pass through and then bounce back. That time will be T2. And the time interval between them, like taking a difference of the two pulses, the time interval of the two pulse, we'll know how much time the radiation is taking within the bubble. Because within the bubble also the sound wave will travel and then it return back. So how much time is this? When I take a difference of the two between the two pulses, that will give us the time the radiation take to travel within the bubble. And the speed of the ultrasound in the bubble multiplied by time interval in the bubble divided by 2. So what it will give? It will give a distance or the size of the bubble. So two things are there. Like first is how to know the position of the bubble. So to know the position of a bubble, we send signal and we receive the first pulse. We record that time. So the time is recorded multiplied by speed of the ultrasound in the metal divided by 2. Why we are dividing by 2? Because it's going and returning back. So this will give us the distance of the ultrasound, distance of the bubble from the position of the detector. Then we are sending a pulse will continue, another pulse, strike back and bounce. That is the total time is T2. So how much time is within the bubble? That will be the difference between T1 and T2. So when we take a difference of the two between the two pulses, that will give us the time it takes to travel within the bubble. So speed of the radiation within the bubble, the time within the bubble divided by 2. So that will give us another distance. And that distance is actually the distance of the bubble, or you can also say size of this bubble. Is it clear? How an ultrasound can be used for detecting the position as well as the size? Anyone having a doubt? Should I repeat or it's fine? The next is the collapse result in a nuclear reaction of a protostar that involved the isotope of the hydrogen. This isotopes of the hydrogen 3,1 is there is a radioactive and it decay by emitting a beta particles. State how the nuclei of an isotope of same element are different. So how the isotopes in isotopes how the nuclei are different. They will have the different number of the neutrons. The neutron number is different, and but we just need a different. They are different because you cannot say they have the same number of the proton because we just need a difference. So you just have to say that they have different number of neutrons. Explain why hydrogen 3,1 cannot decay an alpha particle. Why it cannot decay an alpha particle? Because hydrogen 3,1, the composition of hydrogen 3,1, it has one proton and it has two neutron. To emit out alpha particle, because alpha particle, it must have two protons and two neutron. So this is hydrogen 3,1. To emit out alpha, there must be two proton and two neutron. So it does not have two proton. That's why it cannot emit by alpha emission, right? Or it cannot decay by emitting out alpha. Because it has fewer protons. Minimum for alpha emission, we need two protons and two neutron. But it has only one proton and two neutron. That's why it cannot emit alpha. When there is an beta emission, the nucleon number does not change and the proton number increases by 1. And then the symbol for beta, this is 0 and -1. That is the equation. You have to learn that equation. When a when a nucleus is there, it emit out beta, the nucleon number does not change, proton number increases by 1. Explain how the nuclear reaction in the protostar stop the further collapse as the protostar becomes stable star. When a protostar becomes a stable star, the hydrogen fusion which happen. What is the answer for part 2? Because it has fewer protons. Because this hydrogen, isotope of a hydrogen, it has one proton, it has two neutrons. But the question is why it cannot decay by alpha. Because for alpha emission, it must have two protons and minimum two proton and two neutron. But it has only one proton. So it cannot be an alpha emission. So how the reaction of a protostar stop the further collapse as a protostar becomes stable star? So when in a protostar, there's a hydrogen fusion, the hydrogen fusion releases the radiation which is outward, the radiation pressure, which balances with a gravitational collapse, which is inward. Like gravity is pulling everything towards the center and the radiation is pushing everything outward. So the outward pressure or the radiation pressure balances with the internal gravitation, like the gravitational collapse or a gravitational force. That's how the protostar will become a stable star. So we want to mention how a nuclear reaction in a protostar stops the further collapse. So how to structure the answer for this? So you'll mention the nuclear fusion, or you can also say the hydrogen fusion. Cause the radiation pressure outward, which balances with gravitational force or pull inwards. So the hydrogen fusion, because of the fusion of the hydrogen, it is releasing the radiation outward. And these outward radiation pressure balances with the force of a gravity which is pulling all together. Then the star will be a main sequence, or also called a stable star.
Second part.
Hydrogen fusion.
Second part, it's because there is not enough protons, right?
Hydrogen has one proton.
For
Yeah, fewer protons.
fewer.
The what is for the third part, the answer?
This one completing as this is 0 minus 1 is there, and this is 3 and 4 because 3 and 2.
4 and 2.
Why 4 and 2?
Helium is
No, helium, it can be isotope of a helium. So this nucleon number should not change. In a beta emission, nucleon number does not change. So actually it's an isotope. Yes, after,
It's swallowed.
yes, I recorded. Only 2 I recorded. Like, I mean, 2 questions were there.
Oh, I think और हम लोग जितना भी वक्त ले चाहे अभी रिकॉर्डिंग तो नहीं हो रही
This will check my channel. This will channel.
this is
No, but I have class
other
around
type of
9:45
data,
for A levels. Okay.
other type of information would be
So direction of the magnetic field is into the page. Figure 10.1, mark the gamma. So this is, we have to mark gamma because gamma does not change the direction, not deflected by magnetic field. Then determine the other type of a radiation emitted by the iodine. So what could be the other type of a radiation? How you can identify? You can,
strong current.
yeah, large deflection. Large deflection is there.
And also it's into the page.
And we can also use a right hand rule because it's a, yeah, you can use a left hand. If you use a left hand, it should, for a positive particle, it should go up. But it is going down, so it means it's not a positive particle, it's a negative particle. Index finger is pointing into, second represent the direction, thumb is pointing upward when you use a left. So if it was an alpha,
Yes, yes.
so if it was a positive particle, it should go up. But it's a negative particle, that's why it is going down. So 2 reasons are there. One is the deflection using a left hand rule. It's not obeying that deflection. You can use a right hand to identify the position. And the second thing, there's a large deflection. So type of a radiation which is emitted out, that is a beta. And what are the reasons we work out? Because of one is a large deflection and the direction of the deflection in magnetic field appear to be or opposite to alpha. Because when we work out the left hand rule gives us an idea that where alpha particle will go. Alpha particle will go up. So if alpha is going up, the beta will go down.
So that's for alpha, right for beta.
Yeah.
That's for this.
No, left for alpha.
Left for alpha and right for beta. Or you can use the same left hand. If it follows the rule, it means it's alpha. If it does not follow, it means it's a beta, like opposite. So if you consider, like, let's say if you consider this was alpha. So if you consider this was alpha, your index finger should point into the direction of a magnetic field. So your second finger represents the direction of the alpha. which is toward the right. Where your thumb is pointing? Upward. So means if it was alpha, it should go up, but it's not going up, it's going down. So means it's not alpha, it is beta. So does not follow the rule, obeys the left hand rule, and the second thing is it is the large deflection is there.
So can we say by doing right hand to find
Yes, left hand is actually the rule is left hand.
we use left hand because alpha is a charge, right? It's current. Alpha is like
Alpha is positive charge. Like it's a conventional current. If a velocity is double, what will be the effect on the gravitational potential energy? No, with what sense? Like falling object, you mean?
I think so. Earth
What is a
gravity, right? Sun.
There's a resistance there.
no, like if a velocity is double, which velocity is double? Like object drop?
Orbital speed.
Okay. This orbital speed.
Orbital.
V is equals to 2 pi.
Like for velocity.
Look, what will happen if the velocity, look, for a planet, we assume that the orbit is not circular, like elliptical. So when we compare, when it is closer to the sun, it is moving faster. So like example, moving from position A to position B, it will speed up, speed will increase. But from B to C, what will happen? The speed will decrease. So if the speed is increasing, it means the kinetic energy is increasing. If the kinetic energy is increasing, it means the gravitational forces.
Gravitational.
Wait, he mean the weight, I guess. No, because the question is not like pull of a planet. It's like the gravitational force he mean.
The enforce.
Force, if when it is closer, the gravitational force is greater. But the thing is, because it has a high speed, so kinetic energy is more than the gravitational potential energy. In terms of the weight, when we move away from the planet, like example, if we are on the surface of the planet, the gravity is stronger. Like let's talk about Earth. The gravity on the surface of the Earth is 9 Newton per kilogram. Like the 9.8 Newton, 1 kilogram will experience. But as we move further away from the planet, the force of a gravity decreases. It might be 8 Newton per kg. So the value of the gravity decreases as we move away from the planet. Cannot be zero because the gravitational force has an infinite range. As we move away, the value will decrease, like it will be 0.00001, approximately zero, but not exactly zero. The gravity can be zero in a space. The force of a gravity on an object can be zero if two planets are pulling the object with the same force. Because like as we move, why we called certain position as a weightless? Like we move at a point where like Earth is also pulling, Moon is also pulling us, Sun is also pulling. So there's a result is zero. That is the weightless condition.
Positive. There is no.
Isn't there like a place they call zero gravity?
Actually, it's not zero exactly gravity. It's like a point where the objects cancel out the gravity of each other. But for a planet, you cannot say zero gravity. It's a point in the space where the gravitational forces are canceling out. Like there was a formula relating the speed of